Welcome to today's Explainer. I'm so glad you're joining me because right now we're diving straight into a totally revolutionary two-part system that's designed to fix, honestly, what's probably artificial intelligence's biggest flaw. We're talking about a completely new design philosophy that fundamentally changes how machines process information and, more importantly, how they handle the unknown. Because we've all seen it happen, right? You ask an AI a super specific question, and it gives you this profoundly confident yet completely fabricated answer. We call those hallucinations. But to actually fix this, we have to step back and ask a foundational question. What actually happens when AI doesn't know the answer? Well, the core problem is that traditional AI is essentially forced to guess when it's confused. It's hardwired to always spit out a result, which, you guessed it, inevitably leads to those wild hallucinations and incorrect answers that we're all trying to avoid.
Okay, let's dive into this. So, looking at the old way versus the new way, traditional AI basically tries to guess the exact answer right out of the gate. It just drives straight through the uncertainty just to give you something, even if it's completely wrong. But this new innovation, it takes a radically different approach. Instead of forcing a final answer, the system is designed to find what is absolutely certain, and then, and this is the magic word here, it stops when it's unsure. No guessing. It just pauses right at the edge of its own certainty.
And that brings us to Innovation 1. Knowing the limits.
So how do you build a system that actually knows its own boundaries? One that draws a clear line between what it definitively knows and what it doesn't. Engineers use something called a knowledge tree. Rather than just glancing at an image and trying to guess the exact make and model all in one giant leap, the AI narrows down its focus step by step. So it looks at an object. Step 1, it confirms, yep, this is a vehicle. Step 2, it confirms the brand is GMC. Then, step 3, it attempts to identify the specific model like a Sierra. It's basically a hierarchical chain of logic.
And this brilliantly illustrates why this method is just so powerful. I mean, think about it. If there are 10,000 car models out there in the world, asking an AI, hey, which one of these 10,000 is this, right off the bat is incredibly difficult. By breaking decisions into these hierarchical steps, we're drastically reducing the scope of what the AI has to evaluate at any given moment. It verifies the easy things first, like, is this a car, and systematically shrinks the problem size before tackling the hard stuff.
But here is where the architecture gets really robust. See, this isn't just one single AI making a lonely guess. It's a consensus system. It uses multiple independent AI models all running simultaneously. Let's say we have 9 independent AIs evaluating an object. If 7 out of those 9 agree that it's a car, the system accepts that consensus, locks the decision in, and only then does it move to the next level of the tree. If they don't agree, the process halts.
Let's anchor this abstract concept in reality with a real-world example, the custom ambulance test.
The source material actually provides a fascinating look at this in action. The AI was fed an image of a uniquely modified American ambulance that it had never seen before in its training data. Under the old system, the AI would have panicked, right? It would have hallucinated a wrong model, confidently calling it a Sierra just to give an answer. But using this new systems logic, it successfully confirmed vehicle. It confirmed GMC, and then, because the independent AIs couldn't reach a strong consensus on the exact model, it gracefully stopped at unknown model.
Now, the crucial point here is why stopping at unknown is actually a massive victory. First off, it completely avoids false answers. Second, it explicitly identifies the exact edge of its own knowledge. And third, it flags these unique edge cases for human review. When the engineers actually reviewed this specific unknown result, they discovered it was a highly customized GMC vehicle used as an ambulance. The AI didn't fail at all. It correctly identified a gap in its knowledge, turning what could have been a hallucination error into a really valuable human discovery.
But wait, because it gets even better. This leads us right into Innovation 2, Meta AI.
So the obvious question you're probably asking is, what does the system actually do with that unknown result once it hits the brakes? It doesn't just throw an error code and go to sleep. No way. This is where we introduce the concept of the digital decision signature. When that first AI hits the unknown wall, the system takes a highly detailed snapshot of exactly what was happening inside the AI models at that precise moment of uncertainty. And actually, it's really important to note that it only records this data for the models that successfully agreed on the previous step, which filters out the noise to capture a pure signature of doubt. So what exactly is inside this signature? Well, it captures several critical data points: the number of AIs that were in agreement up to that point,
the average confidence level among them, the variance, meaning how much their confidence levels differed from one another, and the specific individual confidence distribution across the models. This incredibly rich data forms the very foundation for how the entire second layer of this system operates.
Now, you might be wondering, why go through all the trouble of capturing complex variance and distribution data? Why isn't just knowing the average confidence enough to tell us that the AI is confused?
Now, what's really interesting about this slide is how it breaks down the math. Let's look at event A. We have 3 AIs, and they all have an 80% confidence level. So the average is 80. Now look at event B. AI1 is 100% confident, AI2 is 90% confident, but AI3 is practically flipping a coin at 50%. The math works out so that the average of event B is also exactly 80%. If you only looked at the average, you'd think event A and event B were identical situations, but they represent completely different internal realities.
An 80-80-80 split means all the models are experiencing a uniform, mild uncertainty. But a 190-50 split, that is a highly conflicted decision pattern. One model is absolutely sure, and another is completely lost. Capturing this variance is absolutely crucial because it allows the system to distinguish between very different types of uncertainty based on those underlying hidden patterns.
And that is exactly what the Meta AI does. Let's clearly contrast the roles here. The first AI's job is object recognition. It evaluates the data and asks, what is this? But the Meta AI, it operates on a completely different, higher cognitive level. It doesn't care about the object at all. It looks at the digital decision signatures generated by the first AI and asks, what is the pattern of this judgment? It's literally recognizing the process, analyzing the behavior of the first AI when it gets confused.
And all of this leads us to a smarter, safer future. When you step back and look at this whole shebang, it truly paints a picture of an AI architecture that is fundamentally more mature in how it handles the data it lacks. I really want to read this powerful quote directly from the source material because it just perfectly summarizes the brilliance of this dual-layer design. The first AI recognizes objects. The Meta AI recognizes the recognition process. It's a profound shift from an AI that just computes to an AI that actually observes its own computation.
Ultimately, the real value of this system is that it abandons the dangerous practice of forcing answers. Instead, it creates this brilliant, self-improving loop. Step 1, it confirms certainty step by step. Step 2, it safely stops the very moment it hits an unknown. And Step 3, the Meta AI steps in to learn the specific digital patterns of those unknowns. It's a system that actually gets smarter from its own moments of doubt. We've officially moved from an AI that blindly guesses to an AI that maps the very edges of its own ignorance. And that leaves us with one incredibly fascinating thought to wrap up today's explainer. If AI can now successfully identify, record, and learn from its own uncertainty, what limits can't it break? Thank you so much for exploring this with me today, and keep questioning the patterns around you.